Hello there, Neil McGee here with the UVA Computer Science Department with CS 4740 Cloud Computing. I'd like to give a little overview here and try to keep it pretty brief about the types of languages used when computers are speaking and communicating with one another. It's nice that we use anthropomorphic things like speaking and talking and so on to kind of personalize it, but these are exchanges of payloads. These are messages being sent back and forth. And we do this all the time, whether we realize it or not. You know, you're sitting around on this state-of-the-art computer here. You know, you're using your phone, you're using an iPad, you're using a laptop or whatever, but you're sending and receiving responses, you're sending requests and receiving responses constantly to your email server, to a web server. You know, you're watching Netflix and so on. And the response on the other end, it really doesn't matter what sort of machinery or gobbledygook or whatever's going on here, as long as it speaks something intelligible back to you over the internet, something that your client application can parse and make sense of. Maybe that's an email program, maybe that's a web browser, maybe that's Spotify, whatever. It doesn't matter because everything's sort of been normalized in a language that can be sent and received and understood. So what I want to do today is break down the two primary forms of the languages that we've been seeing really for the last 20 years, and maybe with a little nod towards what we're going to be seeing in the future. But the two languages are XML, Extensible Markup Language, and JSON, JavaScript Object Notation. So let's kind of break down XML first. Both XML and JSON are they're hierarchical, and so they are comprised of these element trees. So basically, you can see nested elements. You know, you might see one property like purchases, and then underneath that could be a whole array of several purchases. And think about your history in Amazon.com or maybe your history in Netflix of like movies viewed. It would iterate through a list of things, and all of those are different sorts of elements nested at a certain level. And so we have this. We have another metaphor we're using here of parent elements and child elements that are beneath them, and sibling elements that are maybe next to each other. You know, multiple children next to each other. And in XML, we have a few different things going on. First, we have a declaration header. So good, true XML always has to sort of declare itself as XML and be understood that way. And so in some strict parsing, sometimes that just won't fly unless that declaration is there. You can have comments in XML, so that won't break anything if you insert a comment anywhere along the way. You're going to see the nested hierarchy, like I mentioned above, and that's going to be made up of two different things. So you can have elements with tags and values within the tags and things like that. But you can also have these attributes that are in line. And I thought it'd be good to maybe show you an example of this, a really simple sort of made up example. So here we have our declaration header at the top. This is helpful because it's telling us what version of XML to conform to, and sort of, if we wanted to lint this, we would lint it against XML 1.0. XML's been around so long, I'm surprised it's 1.0. I don't know. It's not gone very far. I don't even know if there's a 1.2 or 3. Encoding is pretty important because we need to know what sort of characters to expect here. UTF-8 is the most universal, most open, most bare bones sort of encoding for any text. And you need to remember, the contents of any XML or JSON are text. We could send binary along in there, but it's going to be in text format. So everything is coming out as text and sent and received as such. We can see a comment here. So there's a list of bookstores. And then we have this nested hierarchy. And so you can see here's the bookstore tag, which closes and encapsulates everything. And then within that, we basically have an array of 3 entries: 1 book, 2 books, 3 books. So the books themselves are children of the bookstore. And then each book element also has 4 more values as children of it. And, the nesting is pretty obvious. You don't have to have this nested, and oftentimes XML in the wild will not have this nice formatting and kind of look pretty like this. And then we have 2 things. maybe it's good to take them in reverse order a little bit. One is you're going to see an element wrapped in tags. So here is the year element, and so we're going to have a year opening tag and a year closing tag. What's nice is that these are completely arbitrary. You know, I could make up a whole new category. I could just say rating, and I'll close that rating tag, and I could just say, you know, let's say it's a 10-point scale. I'll say 8.2 of a rating. So what's nice is that XML is extensible, meaning I can create and populate whatever elements I want to, as much as I want to. However, the one caveat of that is if I had this element in one of my values of the array, I would need it in the others as well. Even if they didn't exist, even if they had no rating value at all, they should be there. So maybe we'll make this one 8.1, this one is nothing, and this one is 8.2. So what I'm expecting is a consistently populated record every single time. And that way I can write code predictably against it and say, okay, I'll do a for loop and I'll say, okay, for every book, give me the title, give me the author, give me the year, price, and rating, and so on. And help me populate some variables that maybe I display on a web page, or maybe that I spit into a database or something like that. So that's the first thing, tags. You'll see them opening and closing. Notice that I don't ever wrap these in quotes. You know, I don't have to put quotes before or after it, whether it's a number or a string or anything, or a float. They're already wrapped. They're already wrapped in an opening and closing tag. So you won't see quotes in the actual values of the tags. Where you do see quotes are what we call attributes. And this is sort of an inline attribute that's basically commenting on the title here. You notice we don't have another nested tag pair here that says language. We actually have this attribute for the title itself that says, okay, the title, the English title of this book is Everyday Italian. Or if we go up to the top, you can see in the XML declaration, you know, we have two attributes. We have aversion, we have encoding. So these little elements are basically describing the element that they are contained within, and so they're contained within the opening and closing tag. Now, here's the truth about XML. When I first started doing really dynamic web programming in the late 1990s and early 2000s, XML was it. I mean, XML was all we had, and so you learned how to build and parse XML freely. If you've ever heard of RSS feeds are basically a simple, nice, happy version of XML. They operate on XML. To this day, I'm fairly certain. I don't know. I'll have to go back and check on this. If you go to the iTunes store, or if you go to maybe the API coming out of a podcast, any sort of podcast subscription service, at least for years and years, they all used XML, and I'm pretty sure they continue to use XML. Who knows? Maybe they moved on by now. I might be dating myself there. XML was the one and the only way to go. And that's because it gave us a nice predictable structure, as we've already kind of seen. It was flexible enough that you could put any values you wanted in there. You could stuff it full of things. And I have one more file. I'll save this. And I have one more file, which is sort of a real. This is actual. I swiped this off of a server that we use to integrate a web authentication with NetBadge. So this is a web app, and we need it to speak with Shibboleth, which is an Apache. Well, it's an authentication mechanism that plays nicely with Apache, the web server. So here is by the way, you see no declaration that says this is XML. We do have this header, though, with all sorts of attributes inside of it. We have all sorts of comments. This we're using we're declaring an entity ID here, and we're going to get the values of a remote user. So the user ID, the EPPN, which is your email, nem2p@virginia.edu, persistent ID, targeted ID, then all my cipher suites, and I can set up a session. What kind of SAML do I want to allow? SAML 2 and SAML 1. all sorts of admin features and so on. I can map to my attributes, and you'll see it maps to a local file here to make sense of what attributes I'm getting back, and so on. My keys, blah, blah, blah. These can go on really long. Sometimes shibboleth declarations have like a big 509 signing certificate like chunked in the middle here. It looks really ugly and things like that. But this is totally production. This is what we use in production still to this day. They've not moved to JSON at all. JSON is the newer, cooler, lighter, more flexible sibling of XML. I think it's superior in many ways. I really kind of cringe when I still have to see and generate XML too much. I'm used to editing these files and making them do what we need them to, but really JSON's the current best practice for doing that. So let's flip over now to JSON, and I'll show you the structure of that, and then I'm going to show you just a little example of getting back some JSON from an Amazon Web Service called SQS, and then I'll show you a little bit about how to parse that with JQ. Hang on. Okay, so when we look at JSON, so JSON was a lot designed to be a lot lighter, a lot more flexible, and really there's a lot less required of it. You'll see there's no declaration at the top, there's no attributes inline or anything like that. There are no comments, there's not a way for me to comment anywhere within JSON. The formatting may or may not be there. This has been prettified. But it might be completely inline, all in one line, to be honest. And what you'll see here are two different things. There are basically just two different types of elements of JSON. One is what we call an object, and an object is simply a key-value pair. We've got a key, we've got a value. The key is, it could be alphanumeric, it could be a string, whatever. It usually would be restricted to certain characters, or would be disallowed. But then my value is, if it's a string, it can be quote wrapped. Well, if it's a string, it will be quote wrapped, but it could have spaces in it. It could have all sorts of special characters and umlauts and whatever. Things that are UTF-8 compliant. But then you'll notice other objects, if the value is an integer or a float, it doesn't need quotes wrapping it at all. So it's a little bit lighter in that sort of way. You'll notice that each one of these, so here's an entry, one of two elements of my array. You'll notice that they're all comma separated. So the commas continue until the last element, because it doesn't need a comma. There's nothing after it, so no commas needed. So that's the first element, is an object. And then the second is just an array, and all of these two objects, both of these two objects, are elements of this actors array. So the array is called actors, and then its value has these heart square braces, and then within there are two sets, and you'll notice that they too are comma separated, and that the comma comes first, but doesn't come in the second spot. You'd actually get a linting issue if you tried to lint this. There's a great tool called jsonlint.com. If you have any sort of JSON and you're wondering if it complies, if it's like, hey, is this neat enough? Does this cut the grade or not? Throw it into JSONlint, press the validate button, and it'll tell you right away. So what's nice though is I can just as easily do for loops on this. I can grab out what I want to. It's not uncommon that you might have something missing in a particular loop. You know, your code is going to have to handle that. If it comes up with nothing, no birth date for Robert Downey Jr., then you just need to know how to handle that gracefully, which is really similar to XML. XML is just generally a lot stricter though, that those elements need to be there or it wouldn't conform to the XML standard. This would be completely compliant with JSON. So for the last little bit of this video, I'd like to just show you working with JSON sort of in the native AWS style. JSON tends to be the language that we speak between every service. Whether you're having a computer or a Lambda function or something do that on your behalf, or whether you're doing it by hand, or whether you're working with code using one of the SDKs, JSON is going to be the API language of choice really, and there are no other options. I mean, in the command line, you can output it as clean text if you want to make it readable and so on, but it's actually arriving as JSON. So what I'd like to do is work with a great service called SQS. So I'm going to use the command line tools here within Bash. SQS is the queuing service. I'm sure we'll touch on this at some point in the semester, but when you have a really large distributed app and you start to have a ton of events going on, maybe they're purchases or transactions or whatever, it's usually not best to try to scale your infrastructure immediately up to take care of everything automatically. In the moment, you could just throw all those requests into a hopper, a big message queue, and then you just write some processes to go get those messages and work on each of them one by one. And you could even set up a side process that says, oh, hey, when the queue gets more than 1,000 messages, backlogged, why don't we scale up a little bit? Or when it's more than 100, why don't we scale up by a factor of 3, or an order of magnitude larger, or something like that. So imagine a fleet of Lambda functions that are all kind of churning through this queue. You could go from, basically those Lambda functions can just go at it, and you could just start to scale them and send a lot more at a higher frequency to eat through your backlog. Anyway, SQS is a great way. Think of it like a deli counter where somebody, gets a ticket number and then they call upon them. So there's two sides. There's feeding the queue with new messages, and then the other side, which is getting messages out of the queue. So first I want to say AWS SQS list queues. List all my queues, please. I have none. That's what I expected. So I'm going to create a queue. And I have to give it a name. I'm going to name it demo. You'll see right away I'm starting to get some JSON back. So I got one object here, queue URL. This is actually really handy. This is sort of the way, this is the API I will be speaking to for all my queue transactions. The command line tools are great because they kind of wrap my authentication around it and let me talk to this freely. You'll see the structure of this is the SQS service in the US East 1 region. Here's my account number, and here's the name of my queue. So it's pretty logical order. So that's great. Let me now what I can do is I can send a message into that queue. And messages can be really, really simple, like what I'm about to do in a second, or they could be a lot more complex and a lot more structured. I think the limit right now is 256K for the entire payload. But the structured, think of a structured message, it's like an email, but with a whole bunch of other fields. I could have a project field that says, it's a key value pair of what project is this with, and who's the owner of it, and what's the deadline for it, and, I could send binary data as part of it, and so on. But I'm going to stick with a nice, simple message here. I'm just going to submit one into the queue. AWS SQS send message, and then I have to send this queue URL. And then I have just one simple field, which is message body. Hello world 1. I'll just say that. And I'm going to send it. I get my MD5 of the message body back. So, and then here's the message ID itself. So if I were to run hello world 1 through an MD5, this is what I would get back. Here's my message ID if I'd ever like to, correlate that ID to something else. I'm actually going to scroll up and send another message, hello world 2, maybe another one, hello world 3, another one, and one fifth one, 5. Great. So now I have 5 messages in my queue. And at this point, I can remove my message body, and I can go back here, and I can just say receive message. And this is all that I need, AWS SQS receive message and my queue URL. And what I'm going to get, you're going to see, I'm going to get some random 1 through 5 here. I don't know which one I'll possibly get. I couldn't tell you beforehand. There are 2 types of queues. This is the standard sort of queue where a message goes in, and when you pick up a message, you just get a random one. It's whatever the machine chooses for you. But they do have, and this was introduced later, they have something called a FIFO queue, F-I-F-O. That means first in, first out. And that's really like your Katz's Deli, in Manhattan. There's 100 people in line at lunchtime.
and they call number 29, then they call number 30, then they call number 31. That's in taking things in order. And sometimes that's really important. Sometimes it doesn't matter at all. If these were jobs to generate PDFs off of some image file or text document or Word document or something like that, and this is happening at night, in the dead of night, who cares what order it happens in? What's important is that they happen. So anyway, let's go ahead and pick up a message. Aha, hello world 5. Let's try another one. Okay, hello world 1. We'll try one third one. Hello world 4. Okay, what you see in each one of these is a nice little bit of JSON. I'm receiving one and one only every time, so my array is always just one message long, so that's kind of handy. But you can see it's a messages payload, and then inside of there is my array of one, just has 4 fields. It has a message ID, which we've seen before, a receipt handle, which is a really long hash. And actually the handle, the only reason I need this handle is to delete a message. That's the one element I need to delete it. I don't even need to call it by ID and the handle. It's just the handle. Then I get that MD5 one more time if I want to verify the integrity of my body. And then I finally get my body, hello world 4. Now I could take this command, and using Python, I could easily parse that JSON, or in the command line, I can easily parse it using a tool called JQ. On Macs, you can brew install JQ. You could pip install JQ on a Windows machine or a Mac or Linux. But I want to say JQ, and I happen to remember it was messages, was my field up above. So I want to filter that. And I happen to know this was 0 indexed, and I only got one message, so I could just say messages. And then I want to get the body field out. I'm going to wrap this in a single quote. JQ is a nice command line tool that lets me just filter that JSON on the fly. So I'm piping my output into JQ, and I want to winnow down into the messages object and get out the first item of the array following that, and then I want to get the body out of that. And so if I hit return now, I'm going to get one of my hello worlds. Hello world 1. Now I can hello world 4, hello world 2, hello world 3. I should get 5 now, and watch one more. I get nothing back. And the reason I get nothing back, this is a little more on SQS, is that every message has what we call an invisibility timeout, which means once you pick up a message, once somebody reads that message, it's not visible to anyone else for a certain amount of time. Now, by default, that's 30 seconds. But just think if I was a process who's getting this message and I need to do something with the message, maybe I need to complete some computing operation, or I need to do some job in Spark or an HPC cluster or something like that. I might need 20 minutes, or I might need 2 hours to do my job. And what's going to happen is if the timeout expires before I'm done and delete the message, well, then some other process is probably going to come pick up the message and start doing the exact same job I'm doing. So it's bad form to have your invisibility timeout too little, because you really don't want to waste resources just doing and redoing the job over and over again. So you want to figure out how much the average job takes, and then add a little bit of time to that, and that's your invisibility timeout. 30 minutes is great for it. 30 seconds is great for a demo, but not really for the real world so much. By the way, you want to prepare for the case that sometimes things get executed twice. Sometimes the same message might get picked up 2 times, and that operation happens 2 times. So devise your solution safely and accordingly. And if it doesn't really matter that PDF was created 2 times from that Word document, then so be it. That's fine. If it meant cutting a check for $5 million and that happens 2 times, that's really bad. So there are situations where redundancy is perfectly okay, and there are other situations where it's not. All right, I've spoken for more than 30 seconds, so now I could go ahead and pick up one more, and there I have 5 back. So that is my, that's using JQ to kind of filter down a little bit. The last thing I'll do is just show you, for sake of a complete example here, I'll get a message out. And what's nice is that if I'd like to go ahead and delete message 2 here, then I can just say SQS, AWS, SQS, delete message. And I need the queue URL again. I always have to have that URL so I know which queue I'm talking to. By the way, in our account in production, we have about 40 queues. It's not uncommon at all. And then we're going to add one more field, which is a receipt handle. And I'm going to wrap that in quotes because it's got a lot of ugly characters in it. So AWS SQS delete message to this queue with this receipt handle, and boom, it's gone. So if I iterated through this over and over again, I would never see message 2 again. It's gone. And that deletion of a message is critical. You have to delete when the whole process has succeeded and you've done what you need to do with the message. You've got to delete it. Otherwise, it's just going to sit there and linger for days and days and days. If messages do linger for too long, you can create what's called a dead letter queue, and that's where all the sad little messages go to live out the end of their days in the dead letter queue, neglected and forlorn by all the processes out there. Anyway, I hope this was helpful. That's about this is the understanding XML and JSON and how we use JSON in the AWS ecosystem. Thanks so much. Bye.